what we are going to apply the normalization while doing the monitoring and verification of this PAD scheme. Because till date, these documents were not circulated, and what Mr. Sethi also said, the benchmarking. See, this is the first time, if you can see anywhere in the world, for aid sector, it is not the plant benchmarking, it is the process benchmarking processes going on. It is not the gate-to-gate energy consumption will reveal, yes, this plant is efficient and this plant is inefficient, and which is most commonly used in the IA documents and other sector, because the geographical condition, the raw material condition, the vintage condition, the availability of the resources are the main criteria to assess the plant performance of any designated consumer. Maybe the time is short, I will go a little bit quickly. In case if the chairman permits 4 or 5 minutes, I can continue. So I am not going to 144 power station, it is you very well known. You know how the target for this power station was set up. It is not the gross, Mr. Bhartia also mentioned. Even 0.1% reduction in APC, you can get 3 kilocalorie reduction. It is not we are interested, because what we have got the large variation in auxiliary power consumption also, and it is because of certain deviations. And this, you know, how the percentage target was fixed. For 144 power station, if all the power station will operate to the design value, the total potential comes near about 15.5 million ton oil equivalent. But under the PAD scheme, which is not possible, the target for 144 power station was given only 3.1 million ton of oil equivalent, or you can say hardly 20% of the potential. That's why nobody can say that you are forcing us under the PAD scheme to go near to the design value. We never want actually. It is a PAD cycle 1, it is a phase 1, and we want actually at least station, the industries, large-scale industry should know what exactly is their performance, and we are very much glad the feedback which we are getting from all the 478 designated consumer, that at least the process of the process benchmarking has initiated due to this PAD scheme. What normalization? This is the most crucial thing, and all the power station has to maintain this document. The normalization is the reasons by that the power station is not unforeseen reason, which is beyond the reason of the power station, by that the power plant performance has deteriorated. Few of them I am just talking to you. Yes, if the fuel quality, if the schedule is not available, if the fuel is not available, and some environmental condition, and because of some flood and all this thing, it is shut down, that is not the fault of the power station, by which the performance of the unit has deteriorated, and that factor will be calculated for the individual plant during the monitoring and verification period. So these are the major, the normalization factor, how we are going to calculate, and what are the documents are required, which is necessary for the power station: quality, scheduling, fuel availability, environmental concerns, and natural disaster, unforeseen circumstances. Now coming to the coal quality, I am not talking only the coal quality here, fuel quality. Coal is dominant fuel for the power station. Even in the natural gas, with the design value of the methane percentage deviating today, during the monitoring and verification time, if a gas turbine is designed for the gas, but due to non-availability of the gas, and because of some condition you are going for the naphtha, these are the fuel quality, which we would like to take all this thing in detail. Most of the power station complaint comes that our design was 4,200 GCV with this fuel ratio. Now today I am getting 3,400 or 3,300 GCV with this fuel ratio. And for that, what we are going to do, we are use this formula, which is CA guidebook. What exactly we want, we'll work out the boiler efficiency with the monitoring and verification fuel quality, and then the heat rate of the turbine to go back to calculate what is the design value. Dominant things are moisture and hydrogen in the fuel. Some people say the GCV reduces, the boiler efficiency reduces. We have done the calculation, it is not always true. Dominant is coming in the moisture and this hydrogen component, and that will give you the MNV time, what is the boiler efficiency, and then we'll work out what is the decrease in the boiler efficiency. On that basis, that baseline figure will be adjusted. The important factor for the DC is the documents which you have to produce. Design document of the coal quality as per the OM, what we want, approximate and ultimate analysis, in case it is available. Operating coal quantity, at least the DCs should maintain monthly average of the lots as fired basis. What we are interested as fired basis. Test certificate from coal analysis for approximate ultimately, and a sample from some accredited government lab for approximate, and not regularly, once in 6 months, at least the sample which you have tested in your lab, similar to be tested from some accredited lab. There are complaints actually, the design value varies from the performance guarantee value. If the OEM has given you the PG value, that will be considered as the design value. Maybe you have got the vintage of your boiler or turbine. If the report has been carried out, because of the vintage, the turbine heat rate is this much. During monitoring and verification, if that document will be available, that will be calculated for your design value. Other thing, the PG, yes, there are so many plants where they have given the PG value, where the plant is 30, 40 years old, and because of the vintage, we cannot take the design value. So I request all the DC, in such cases, some study from accredited agency should be carried out in order to assess what is exact the vintage of the efficiency. This is also an important factor, because today what we see, people are saying in the power station, fuel non-availability. And particularly it is true with the gas station and coal also. Because of the fuel non-availability, the loading of the turbine has reduced. There may be two cases. One case, it is a partial loading because of the grid availability. Other is shutdown of the unit. And because of that, there is an increase in the net heat rate. I am not saying if the loading is from 210 to 160 or 140, the plant should work out if it is there for the maximum days in a year, how do you can match the auxiliary power consumption to that loading is the another energy efficiency area.